Have you ever tried to find someone's longest streak of daily activity from a messy log? That's exactly what LeetCode's longest consecutive sequence asks. One of the Pattern Mastery 100 essentials, and a problem that stumped even experienced engineers at companies like Google, Netflix, and Facebook. In interviews, getting this ON trick is a game changer. Let's apply the basic approach. A strategy broader than STAR because it's designed for breaking down technical challenges and system designs, not just behavioral questions. We're given an unsorted array of integers and asked, what's the length of the longest run of numbers that appear consecutively, regardless of order? For example, 100, 4, 200, 1, 3, 2, yields, 1, 2, 3, 4 length, 4. Edge cases? Handle empty arrays, negatives, duplicates, anything the interviewer throws at you. Suppose you're designing a fitness app. You get a list of dates a user logged workouts. How do you instantly show their longest streak, no matter the order the logs came in? This problem is exactly that challenge. If you sort and count, you get ON log n. Good, but not great. The best solution uses a hash set for P01 lookups and only starts streaks at the true beginning of each run. Num, 1 isn't present. That way, you never double count or waste work, making the algorithm ON. Add all numbers to a set so we can check for any number in constant time. For each number, only start counting a sequence if there's no smaller number in the set. Count up from each streak start, tracking how long the run goes. Update the max streak found along the way. Return the result. Let's walk through the logic as if we're coding together. Let's implement solution 1. This comment shows we're solving longest consecutive sequence by sorting and scanning once. This line starts our solution class, the container for our method. Here we define longest consecutive, which takes nums. Our goal is to find the longest chain of consecutive numbers like 1, 2, 3, 4. This checks if the list is empty. If there are no numbers, there's no consecutive sequence, so we return 0. One-liner, set nums removes duplicates, sorted, orders them. Sorting places consecutive values together, making detection easy. ON log n. We create longest to store the best streak so far. Starts at 1. We create current to track the streak we're building. We loop through the sorted list from index 1 and compare each number to the previous. This loop is ON. This checks if the current number continues the consecutive chain. If it continues, we increase the current streak. If it does not continue, we reset the streak. Before resetting, we update longest if current was bigger. We reset current to 1 to start a new streak. After the scan, we return max longest, current, since the longest streak may end at the last element. And that's the algorithm: remove duplicates, sort, then scan once to track consecutive streaks. Let's test our function using this input. These numbers are scattered on the number line, and our goal is to find the longest chain of consecutive values like 1, 2, 3, 4. Why the solution works? We first sort and deduplicate the list, turning it into 2, 3, 4.100, 200. Now consecutive numbers sit next to each other. The algorithm scans and builds streaks. 1, 2, 3, 4 gives a streak of 4. Then the chain breaks at 100, starting a new streak. 100 and 200 have no consecutive neighbors, so the longest streak is 4. And that's exactly what our program outputs, 4. This matches the expected result and confirms our scan found the longest chain. So our implementation is correct. It sorts the values, tracks streaks efficiently, and identifies the longest run of consecutive integers. Now let's try another implement approach using solution 2. This version uses a hash set to check whether numbers exist and to identify where each consecutive sequence begins. This line defines our solution class, a structured home for our method. Here we define longest consecutive, which takes a list of integers called nums. Our goal is the same: find the longest streak of consecutive numbers like 5, 6, 7, 8. This converts the list into a set. A set removes duplicates and gives P01 lookups, which our strategy depends on. We create longest to track the longest streak we found so far. Now we loop through each unique number in the set. This loop is ON because the set contains unique integers. This line is the key insight. We only build a sequence if the current number is the start. If num, 1 isn't in the set, nothing comes before it. Example, 4, 1, 2, 3, 4. We only start at 1 because 0 isn't there. We set length to 1 since any number alone counts as a sequence. We use current to track the value as we extend the streak forward. This loop checks if the next number exists. If current equals 5, it checks 6, then 7, then 8. Set lookups are P01, so extending sequences is fast. We move to the next consecutive number. and we increase the streak length. After finishing this sequence, we update longest if needed. We return the longest consecutive sequence length. Time complexity is O(n) because each number is processed once, each sequence is walked once, and set lookups are constant time. And that's how this algorithm works. Load numbers into a hash set, identify true sequence starts, and walk each chain forward. Efficient, simple, and elegant. Let's test our function using this input. These numbers are unsorted integers, and we want the longest chain of consecutive values with no gaps. Here's why the solution works. The algorithm stores all numbers in a hash set for fast lookups. Then it only starts a sequence from numbers that look like the first in a chain. For example, 0 starts a sequence because -1 is not in the set. From there it checks. Is 1 in the set? Yes. Is 2 in the set? Yes. Is 3 in the set? Yes. Is 4 in the set? Yes. Is 5 in the set? Yes. Is 6 in the set? Yes. Is 7 in the set? Yes. Is 8 in the set? Yes. Is 9 in the set? No. Sequence stops. That gives us a streak of 9 numbers in a row. 0, 1, 2, 3, 4, 5, 6, 7, 8. No other number forms a longer chain, so the maximum length is 9. And that's exactly what our program outputs, 9. This matches the expected result and confirms the algorithm correctly found the longest consecutive sequence. So, our implementation is correct. The algorithm identifies sequence starting points and expands them efficiently to compute the longest chain. Let's have a quick recap. We're given an unsorted list of numbers, and we need to find the longest run of consecutive integers, no matter the order. Conceptually, it's about identifying sequences within disorder, finding those hidden streaks that form continuous ranges. It's a perfect test of both logic and efficiency. A sorted approach works but costs O(n) log n. To do better, we use a hash set for constant time lookups and start streaks only when we see the beginning of a sequence, meaning, when num1 isn't in the set. This clever shortcut prevents wasted work and achieves true O(n) performance. The logic flows like this. Add every number to a set for O(1) lookups. For each number, check if it's the start of a sequence. If it is, count upward until the streak ends. Keep track of the longest streak found. At the end, return the maximum streak length. We built this logic step by step, ensuring each number was visited only when necessary. The code ran cleanly and efficiently. We successfully executed it on LeetCode without any errors. We tested across various cases, scattered numbers, duplicates, negatives, even empty arrays. Every test passed perfectly, and the logic held up across all scenarios. The key takeaway? True optimization isn't about fancy syntax, it's about seeing structure where others see randomness. Once you understand how to detect starting points, you can handle any streak, sequence, or continuity problem with total confidence.